Hey there, welcome back to the channel. So I found the error which is causing our malloc to act weirdly, you can say. So here it is. So what is happening in realloc is that you must know like how realloc works. So realloc takes a function, so it takes a pointer and a size value. So pointer is the previous block that we have. Okay, it's present, and we want to increase the size of that block. Well, we can do two things. If it is at the end of the heap, then we can just increase heap by whatever the difference is. Or if it is not, if its adjacent blocks are not free, then we can allocate a new block. We can call my malloc and free up the old block. So what I'm doing over here is that if I find that my left hand, so this is the logic which handles like if the block is shrinking or stays the same. So this is the logic where the block is shrinking or stays the same, and this is the logic where the block is increasing. Well, the thing is that if we find that our left block is not free, or you can say, if we find that our left block is allocated as well as our right block is allocated, well, that means if my left is allocated and right is allocated, there is no point in like increasing the block, right? That is just fair. So I've used copy block function. What copy block does is that it just calls my malloc, asks for new size, and then we copy the stuff from our current block to the new block. So mem copy to the new pointer, the old pointer, and how many bytes, and then we free up the old block. So this is fine, and we should return it right now. And why am I doing this, and why am I not relying on this? So what kind of mistake that I did over here is that I asked the coalescing RL function. What coalescing RL function does is that it copies the block. Now that I think about it, yeah. What coalescing RL function does is that we give it a pointer. It frees. Uh, it checks like if the left and right block both are free. Then we merge the block, and then we just coalesce copy it. But the thing is that we are not sure if the merging of the three blocks. Okay, my what you can say. My experience skills are bad. Let me do it again. Okay. So what coalescing RL function does is that it we when we give it a pointer, it is supposed to be a free pointer, but we are giving a allocated block over here. It's fine. So we give it a pointer, so which is the current block, and then if the left block is free and right block is free, then to reduce fragmentation, it is beneficial for us to like merge all three of them. So that's what it does, coalescing RL function RL, which means it coalesces the current block as well as the right block and the left block, and it gives a pointer to us. Sorry, and this is the current RL. Now, what kind of check did I forget over here? So the check that I forgot over here is I forgot we should be also checking like if the coalesced block is fitting. Is it enough for our size, the aligned size? But I did not do that check. It should be present because if the check is not present, then what coalesce copy will do is coalesce copy will copy the block, but it might overlap. Sorry, uh, it might. What I'm saying is that it might not be enough. So that should not be happening. That's why we are allocating lesser. Sorry, that's why we are allocating. That's why we're getting so much high score because what we are not allocating what we are supposed to. So, yep. And when we get the check, so when we get this over here, we should add a check if so. Let's see. So let's do this. Let me just check what coalescing RL returns. It returns a header block. Yeah, cool. Yeah. So we go over here and let's just write current. So current is equal to casting into current RL. Cool. And now I will check. So if current size is greater than or equal to, what do we say? I should add a condition over here which is smaller because this is the condition which handles the greater than or equal to stuff. So if our current its size is less than a line size, then in that case, sorry. So if current size is less than a line size, then it is beneficial. No, I'm so sorry. Then we need to increase the size, right? I will add a condition again. So if current footer, how about that? So size t current size is equal to current size and footer block current header, and I will add current footer over here. So footer block pointer current. Oh, sorry, I have to do pointer jujutsu. So current header plus header plus current size. Cool. So now I'm at the footer. So if should I add a current end? Yeah, let's add a current end. So current end is equal to void pointer char pointer current footer plus footer. Cool. Hmm. So if current end happens to be equal to mem heap high plus one, then we can just increase the size. And if not, then we will call my malloc, right? We did not, even after coalescing, we did not find that. So, yep, we will call my malloc. So, void pointer new block. Is new block present? No. Okay. New block is equal to my malloc. We will ask it for a size of aligned size. So, we'll get a pointer to that. We don't need this because we can just copy it to new s. Oh no, we need this. My bad. Oh, we don't need this. New s is equal to my malloc, so we store the new space in my malloc, and then we need to copy it. So mem copy to new s. What do we have to copy? Well, we have to copy from pointer and how much? Well, we have to copy only align size, right? But just to be safe, we will copy just no, not size. I'm so sorry. We will copy the current size. Also, the current size that we get needs to be. We need to remove the LSB from it. Cool, cool, cool. So we copy this, and this is fine. I'll add that into else. No, sorry. I need to just consider what is happening. So yeah, this is it. And if the current end is equal to mem heap high, then size t space needed, yeah, let's give it space needed, is equal to, well, my current size is, what is my current size? Yeah, current size. I should do aligned size minus current size. Cool. So if I need 200 bytes and I have 100 bytes, so now I need only 100 bytes. Cool. So I get 100 bytes from this, mm, and then I call mem is brk. So let's see how what does it return? Yeah, it returns a block pointer. Cool. So that will be the end of the block. Yeah. Oh, messed up. Yep. Space start is equal to mem is brk. We need a space needed, and then we can just get to the end of it. So now this is aligned size. Yeah, now we have to set a footer to it. So what do we need to do is, uh, yeah, let's change the header block values. So current header, yeah, sorry. So current header size will be aligned size or one, and now we have to create a footer. So footer block pointer space footer is equal to footer block pointer char pointer. Well, it starts from current header. How about we not start from current header? Space start plus space needed minus footer. How about that? Or we can, or the better way is, sorry, like a clean way to do it is current header plus aligned size, and I guess that should do it. So current header, select current header, I'll move ahead by header, and I will move ahead by aligned size. So this is cool. So now I'm at the footer. Yeah. So space footer size is also equal to aligned size or one. Okay, this should do it. Hmm. Let's move this out. I do need this. Let's see if this works. If it doesn't, it's fine. I I think it won't work, but we should have our hopes up. So make, let's see if it compiles or not. So current header, yeah, yeah, cool, cool, cool. So this is on 520. The other thing is current RL, header of pointer, use of undeclared current RL, 519, use of undeclared current RL. Hmm. Okay, so I'll declare a current block, and what we can do is instead of this, we can do the what? How about that? There is no else current, right? Yeah, yeah, cool. So current header is not just current RL, it's just current. Oh, it's just current. And then current header, it can't find a current header, current size, 520. But let's see if there are any others. There are a lot of them. So coolness copy can't do RL. Oh yeah, yeah, my bad, my bad. So current size 521. This should be current header. And then use of undeclared warning unused variable. Yes, please start as unused. Yeah, I know it's unused. So let's just do this. We don't really need a pointer to it. So cool. And then redefinition of my malloc, my realloc, sorry. Yeah, also let's comment this. So this should work. Yep. And driver dash B. Oh, it works. And it still gives us 1500%. Hmm. Weird. Very weird. It did compile, right? Make dash G. Oh, sorry. What was it? M driver dash G. Yep. M driver dash verbose. It's still the same thing. 89, 89, 89, 79, yeah, whatever. 57, 99, 65, 88, 1500 and 1571. Hmm. What is causing this 1500%? I have to know this. What is happening inside coalesce copy? So what coalesce copy does is it gets merged one, it copies that stuff, it gets a merged header, split difference, it's merged header size minus size, it splits the block, but it shouldn't split the block. Why did you do that? Oh God. We don't even need this function right now. Yep, don't even need that. We just merge the block, so we don't need this. So we don't need coalesce copy function anymore. Okay, so what do we do with the new space? So we know it's a pointer and we know it's, let's just add the thing ourselves. Sorry, not this one. So we have a word pointer, more space, which is current header plus, yeah, nothing much. So here we get the current header, we get the current size, the current footer, and then we can do one thing, which is current space. So current space is equal to void pointer, whatever the same stuff that they have above. So this is current plus header, cool, and then we mem copy it. Mem copy to current space. We have to copy from the pointer, and how much? Well, it's the block size. Cool. That is good. Yep, so we don't need that function anymore. Let's see what happens. I hope it compiles, and it does, and I hope it runs. It does, and it's still 1500. What is the problem then? Okay, so if left and right are not free, then we don't have anything to do. So copy block, what does copy block do? Yeah, okay, it calls my manner. Sure. Okay, so you're 24 minutes in, that's fine. So what it does over here is that we call copy block. Copy block then does this pointer minus header Hmm. Get the size, call my mallet, get the new block. Okay. I think we don't even need copy block function. Yeah, just keep the current as pointer. How about this? Well, technically, it's a header box, so we do need to do this. Pointer minus header. Nope, still nothing. So left free and right free, both are not free. Then we call current. Current is pointer minus header, and this. Yep, it's not called anywhere. Hmm. We'll just call it E. How about I remove this? This should run at least once. Okay, let's run this for the specific trace file. It doesn't. Well, let's call this printf real exit you boom boom. Yep, it does work. Then I should also see domain expansion, or we can say block expansion. Oh, this video's thumbnail can be about domain expansion. Yup, block expansion isn't called, and it should be called. Is it because difference? So difference is greater than or equal to zero. So this is block size minus align size. Block size is this, and AS is this. Block size, align size. So let's see. Yep. So block size is this 614528, 614528, and align size is greater than that. So align size is greater, this is definitely negative. If this is greater than or equal to 0, and difference is greater than, okay. So I know for a fact that difference, so let's add this to it. So, yep. So this is what difference would look like. I am 100% sure difference would be negative, but just in case. Difference can't be negative. Wow, why did I not realize that before? Crazy. That is crazy. Block expansion difference is this. Why though? So this 512 Oh, is it because of this? This should work, right? Yeah, let's try keeping it simple int. How about that? So this is int, and yep, this is t. So let's see. Implementation realloc failed. Hmm. Why did it fail for trace here? There is nothing in trace here. Okay, trace 0, line 9, line 10. Okay, what is that line 10? Realloc 0 to 768. Okay, instead of int, simple thing, we'll just take it at size t, or we won't even take at size t. How about we just do this? So if block size is greater than a line size, cool, and if block size minus aligned size happens to be greater than or equal to 0, or we can keep it difference. Block size is greater than aligned size. How about that? And we can just replace this with ZU again, and this should work, and it doesn't. Hmm. Let's check where is it failing. So in driver, let's make it in debug 1. Okay, implementation realloc field. We can set a checkpoint over there. Yeah, it's inside mdriver.c 689. Cool. So watch point set line number. Watch point set expressions. What was the other thing? I forgot. Yeah, right. Breakpoint mdriver.c on line number. What is it? 689. Let's run this. How about we set that on validator.h, line number 154. Yep. So breakpoint 2.1, string variables. Hey, let me check one more thing. So if you do this, memory copy and return new s. New s has to be something, right? It cannot be null. Okay. Okay. So I'm not getting this. So the trace file is specifically 9 number because it has a realloc. It doesn't work. So it is this. So we have realloc 640. The AS is this. Difference is this. Sorry. And block expansion. Realloc 768. Block expansion 640, 768. Fine. And the block has to be expanded. Then we get reallocation field. And why is that? Let's check what happened to the previous realloc. So did we go? Well, the block size has increased, so most likely block expansion occurred. And then, yeah, let's write printf ARL. So that means allocated RL. Here we can write, yeah, yep, yep, yep. Here we can write free RL. Here we can write free L. And here we can write free R. Free R. How about that? Yep. So we get this allocate RL. The block just isn't enough. And then we free L because we have left block free. on our left side. So that's cool. Let's print some values. Let's set a watch point on 533. Yep. How about we set a watch point on 533, line number 533. Yeah, okay. The watch point set expressions, not expressions, what was it? Line number. Why do I? Let's watch the video. Let me watch the video, copyright strike or something. Are you guys able to hear this? Okay, so yep, let's do it. So watch point, let's create a breakpoint. So LDBM driver. Yep. Now breakpoint we'll set on allocator.c on line number 533, and then we run. So this is the first breakpoint before doing anything. So frame variable. So we have a pointer size, align size is this, block size, the current block size is 512. The difference is this. Yeah, the difference. Yeah, let's forget about the difference. Left freeze false, right freeze false. There are no free blocks, and hence, since there are no free blocks, we should at least see current size and current expression. Yeah, current space. So this is the current space, and current end is this. So let's translate 220. Let's check what is the hex of it. Hex to decimal. So 220 should be 512 plus 32, 544. So 220 should be 544. Yep, so it's correct. Why did I close that? I'm going to need it. So this is fine. Let's continue. If we hit that again, offering variables are this. So there is a block at the left. The difference is garbage, definitely. Now the current block is at 2C0. So 2C0 must be 704, which is concerning, right? 640 plus 32, 640. Oh, I don't know. So the current size is now 800. What is current size? Yeah, okay. It's a current block size. Is 800 after coalescing. So after coalescing, we have a block of 800 and then it fails. So we do perform mem copyright. So n, we are at this, n, oh, we are at directly US. So current size is smaller than align size. So current size happens to be smaller than align size. Okay. Oh, I did not include the else logic. That is why it's happening. So current size is less than. So what I should do is, so current size is less than align size. So even after coalescing, it is not enough. Then we will check if it is at the end. If it is at the end, then we can just increase the specific one BRK. And if the current size is still less than, hmm, so we do know this. Look, I'm sure that I've written a bad logic, but I'm just thinking like what is the way to go forward? Like how should I write my code? So so first, okay. Let's make it clear. So I'm at 47 minutes. Yeah, okay, cool. So I get coalescing, so I do coalescing. I copy it to the start of the block. Then current size, align size, yeah, sure. So now I have to check, okay, I have merged the sizes. Is it enough? Well, if it's not enough, then so frame variable, current size is 800, align size is 768. So so we should split the block. Yeah, where is the split block function? So split block returns a pointer to the allocated space. You have to give it the current pointer and the allocated size and the difference. So new s is equal to split block. So this would be our current head. Then it will take what is the size that we need. So this is aligned size and this is split difference. So let's check. Okay, seg fault. We did get a seg fault, which I expected actually. Nothing wrong in that. Hmm. So we have, so we find out that even after merging, our current size is actually, even after merging, we find that our current size, so our current block, is smaller than align size. Then we go inside if. Are we getting inside this if? Let's pipe that to output. So output Okay, so inside. Yep, there is no inside. So we aren't going inside this. So if current size happens to be smaller than aligned size, I'm so sorry. The dog, a dog is barking. So yeah, okay. So we copy that to the start of the newly allocated block. So the new coalesced block, and then we find out that the current size that we have is actually less than aligned size. So our block is still smaller. Well, if it is still smaller, then we can call. So we can say, hey, mem heap high. If that is equal, then how about you give us. Why is it doing that though? Yeah, okay. So how about this? It's doing a set fault, right? So what are we seeing over here? So our current header is at this position. Current size is 115712 and 115840. Okay, 11540. So it's happening because of this mem copy, right? At 546. Okay, why is new as this? So new as was null when they reached over here. So current size is this, current my malloc. Wait, my malloc return null. Why did my malloc return null? We ask mymalloc for a size and it returns null. It returns null when boom, it crashes. So current size was 115712 11540. Current space is this, current expression is this, current block, so current is this, yep, over here. So AB8 and AA0. AB8 2744 and EB0. EE0, sorry, 2720, which is 24. That's correct. And then current end is at this 4E, which might be correct. So the current block is cool, but new S, my malloc returned null. Why did my malloc return null? My malloc never returns null, Was not able to allocate stuff or something like that. So it returns null. Um, hmm. If it didn't have this space, it would have called mem_sbrk. Okay. Hmm. Why did that happen? New S was null. My malloc returned null when we asked for align size. Align size was 11540. What is happening? We need to figure this out in this video itself. Okay, this is going to be a big video. So let's think again. Let's remove these. Let's remove the print statements that we don't need. Sorry. So yeah, real, that's fine. Ran out of memory, my SBRK failed. So I'm hoping this is what is causing to have allocate null memory. Hmm. So this return to null, my malloc new s, my malloc return null, and we were not able to copy that. Why did my malloc return null? Let's add a condition to my malloc. If allocator this is equal to null, printf null. How about that? And 264. Okay, so make equal to 1, and then dbm driver. Set a breakpoint on allocator.c. What is the line number? 264. 264, yep, set. And then we run this, traces, 9. Cool. So it was the millions Byakeval. Okay, let's add the same stuff above. So if space is equal to null, printf null. We are not getting anything. Ran out of memory 528344. Yep, 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 yep. It's because of memcopy new s, new s, new s, new s. Oh, I did not set new s over here. So, yep, okay, I forgot. So, if this is equal, then new s is the current s itself. Is that cool now? Was that it? Yeah, okay. Huh. It is not equal to. How about 545? But a watch point on 545 will be bad. Sorry. So, yeah, we are returning new years. Universe is null. My malloc did return null. I know for a fact it returned a null. Is it before Memes Biake? Is that it? Yeah, okay. So new. So this is increasing rapidly. So we are constantly asking for new memory. Hmm. So the block isn't free. Is that it? Ha! We aren't freeing the old block. So whenever we are calling mymalloc, we get a new pointer. So that's cool. And then we copy it. But we forget to free the freaking, oh, sorry, my free pointer. Sweet little pointer. This should still not work, but oh, it works. And it's bad. It's working bad. And why is it working bad? Because 65, 68, yeah, it's still increasing. It's still increasing. Oh, increasing by a lot. Uh, so it increased by this much. What is this? What is this value? 74. Ooh, that is a bad case of internal fragmentation. So the first alert took 220 and then 2C0, then 560. So it increased. Yeah, it keeps on increasing. That should not happen. So this is happening because wait, let me do split dot. No, nothing in split dot. So then, so inside this if yeah, let's remove that too. So it's never finding a block. Wait. So it keeps on increasing it. Should I do this? So mem is PRK plus one. Is that the answer? Let's still that. What might it be? What might it be? Why is it calling new again and again? So it new. Sorry, printf. Yeah, okay. So it's calling for new again and again. Let's remove this. Also, let's remove this. Get def is this. Wait, sorry. Yeah, we didn't need that functions anymore. Cool. Block size greater than line size. And block size greater than line size. Current null. Current newest. We don't need newest. Oh, right. We don't need newest. So why are we maintaining newest? Not sure. Hmm. Sus. Very sus. Hmm. If I run it completely, so make lm driver dash f trace is 9. That's bad. If I don't make, yeah, let's run in driver dash v. Yep, it's 66. Utilization is 2%. That's bad. These scores are fine, but utilization, yeah, 2%. Oh, sorry, this is utilization, I forgot. So, yeah, this is fine, this is fine. This utilization 34%, not good. Wait, let me just check one thing. So, this is like the average, right? So, this is like what, 5 and 5 again, yeah, 10. So, if I take the average of all of them, so 88 plus 89 plus 89 plus 80 plus 57 plus 99, 65, 88, 34, and I do divide by 10, so 76. Hmm, okay, so roughly what kind of value do I need? So I got 760 minus 34, and what should be 726 plus x such that our value is at least 90. So 726 plus x divided by 10 is at least what is a good utilization score? Let's consider 18, 800, 726. Yeah, at least 724, and we are good to go. How do we do that? So we are copying the thing. So if current size happens to be less than aligned size, and it is mem heap high, how about I print what is the current size? How about that? So let's say current e end is at pointer and high is at pointer. Let's see what does it give us. So this is current e and mem heap high. Okay, so my current end is at this 8D9A0 and my high remains the same. Why is that? Hmm. Let's not run this. How about we do this, places, and let's get the output byte. So it's over here. Okay, okay. 01486BCF8. So what is this? 86B 86BCF8. 86BCF8. 88386. 95 EE0. This is the highest we reach. 614048, which must be the last one. How much was 614048? 614048. 614048. Which is this plus 32. So at this real, this is the highest we reach, and then we free, 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 free. Then we free everything. Hmm. Let's do a dry run. How about that? Let me show you guys dry run. So I will demonstrate like how this allocation works on whiteboard. So yep, let me read stuff. So initially we have this block, not this block, but this is our heap. The okay, let's try again. No problemo. Nice. So initially we allocate a block of 512. Is it visible to you guys? Like the number and all? Yeah. So initially we allocate 512. Then we are supposed to allocate 128. Then we have to reallocate 0 to 640. So this to 640. But since space isn't there, we have to directly allocate it. So this is reallocate 640. Yeah. Hmm. So we have 640, reallocate 0 to 640. We have a free block of 512. So this is freed. Then we allocate 128 again. We can allocate just inside this. So this becomes 128, and this will become what do we call 512 minus 128. So this is a bigger free block. Just 512, they allocate 128 of it. The remaining thing we have to split it. So 512 minus 128 is 0, 12, 4. 50 minus 12 is 40, 38. And even in this, we have to reduce 32 because the header and footer of the split block. So this is 2, 5, 352. So this is 352, and then we free the first block. So the first block was this one. I should write numbers on their head. So this is still 0. Yep. And allocate 2. So this is 2. Yeah, okay. So free 1. So 1 is freed. So these two will be merged. So 352, 120. Oh, I should write numbers very neatly. 128 and also 32 because we don't need double two or headers and footers. So this is 2, 1, 7, 3, 10, 1, 1, 5, 1, 2. So this is 5, 1, 2 again. Nice. 5, 1, 2, and it's free. Then we reallocate 0 to 7, 6, 8. Well, as you can see, now we can just increase the size. So this will just increase the size to 768. Easy, easy peasy lemon squeezy. So yeah, then we allocate 3 to 128. Allocate 3 over here. So this is 352. Cool. This is 352. This is free. This is still 0. Then we allocate 3 to, yeah, we did this. Then we free up 2. So this is free. Reallocate 0 to 896. So this is again 896. Then we allocate 4 128. Okay, so this is now not free. Allocate 128 means I should maintain a free list. So this will be allocated over here. Then we free 3, then reallocate 0 again. Yep, this keeps on happening, I guess. So this shouldn't be taking a lot of space. At the end, mem heap high should reach a maximum of, as they said, um, I don't remember. What was it? What was the maximum that we reached? 95 EA0. 614048. No, sorry. Yeah, 614048. This is what we reached at the maximum position, which is fine. This is the end of the block. Why is my high not changing? High should change, right? Sorry. Oops, sorry. I don't want to do this either. Okay, so it starts off cool. Okay, now it should increase. It doesn't. Hmm. Let's also try printing mem heap below. How about that? I was printing the functions. Like, what is the instruction for that? Like, where is the function located? That's what I was printing. Dumb. Yep, I'm dumb. So yeah, Okay, we don't need the sleep now. What is happening? Let's try doing the heap high -1. 8 it's still 11. The throughput is also very bad. Utilization is 34%, which is bad in itself. 66, very bad. Throughput is also 2%. Yeah, let's end this video. Oh, I wasn't. Wait, why isn't it working? Oh, wait, did I mess up? Okay. Okay, so it wasn't visible for you guys. I'm sorry. Yeah. Let's end the video right now. How about that? Because so I have exams coming up. So today is 17 November. I'm making these videos uh like on 17 November, but you might be watching this video on 26 maybe. Yeah, you'll be watching this video on 26. So that's because my exams are going on. So I'm like pre-recording these videos. So yep. Uh, yes, that is it. If I find time, so I won't be able to record videos. So if I find time, then I will most likely debug it. Uh, like I'll try to make a video if I do find time. So I guess that is it. So thanks for watching this video. I'm Aditya Vacharni, and I am an engineer for fun. Bye.